Welcome to our guide on protecting your web applications against cross-site scripting and SQL injection attacks on Google Cloud. Our main defense strategy revolves around using Google Cloud's load balancer, which will be the star of our protection plan. Let's start by understanding what might be behind your load balancer. You could have different types of systems such as Kubernetes Engine Service, Compute Engine Virtual Machine, or even serverless options like Cloud Run or Cloud Functions. The key point is that all your internet traffic should go through a cloud load balancer. In our example, we're using a Google Cloud project with a private Compute Engine instance. This means our VM doesn't have a public IP address, which helps prevent unwanted access through the network. Instead, we're directing all traffic through a network load balancer where we'll set up our protection. To make this protection easier, we'll use a tool called Cloud Armor. Cloud Armor policies allow you to protect your VMs at the network's edge. This means that even if your virtual machine is in one location, like US Central 1, the protection against cross-site scripting and SQL injection will happen at many different Google Cloud locations around the world. This approach helps reduce the work your server needs to do. We've already set up a basic backend security policy on our load balancer. Right now it has a simple rule that matches requests to admin PHP. This is just the beginning of our protection strategy. Let's take a look at what we're protecting. If we check our load balancer, we see a basic Apache web server with a default HTML page. There's also an admin PHP page, which our current Cloud Armor rule is watching over. Now, let's add more protection. We'll create a new rule using the advanced mode. This rule will guard against cross-site scripting attacks. The example code we'll use is based on a pre-configured rule from OWASP CRS 3.3, which is a set of well-known security rules. You can find more details about these rules in the Google Cloud documentation. Now let's set up our protection rules. For the cross-site scripting XSS rule, we'll configure it to deny access with a 403 error if it detects any XSS attacks. We'll see this rule to a relatively low priority in our security policy. Next, we'll add another rule to protect against SQL injection attacks. This rule will also respond with the 403 rejection for any detected SQL injection attempts. It's worth noting that Cloud Armor offers many more protection options beyond just injection attacks. You can easily add these rules using the simple, declarative configuration in the Google Cloud Console. For our SQL injection protection, we'll also set it to reject with the 403 error. We'll give this rule a reasonable priority in our security policy. Now we have a web application firewall set up to protect against both cross-site scripting and SQL injection attacks. With our defenses in place, it's time to test them out. We'll use the Google Cloud Console to simulate requests to our protected endpoint. First, let's try a normal request. If we use a simple curl command to access our website, we still get the regular Apache 2 page. This shows that legitimate traffic is getting through without any problems. Now, let's try to simulate a basic SQL injection attack. We'll send some data that looks like it might be trying to manipulate our database. When we send this request instead of getting the normal web page, we receive a 403 forbidden HTTP response. This means our Cloud Armor rule has successfully detected the potential SQL injection attempt and blocked it. It's important to note that our website isn't actually processing this posted data in our HTTP request. In a real application, you would still need to implement proper input validation and sanitization. The Cloud Armor rules are an extra layer of protection at the network level. If we go back and make a normal request again, we'll see that we can still access the Apache 2 homepage without any problems. This shows that our protection is only blocking potentially harmful requests, not interfering with normal traffic. If you'd like to support the channel, get a free trial of our new design tool in the video description and let us know what you think. We'll keep an eye on the comment section for any questions and want to thank you for watching. Please enjoy responsibly.